Na 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 na, dapat Tagum radyo eskwela na. Na 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 na, dapat Tagum radyo eskwela.
Hello, grade 11 students. This is TV High welcoming you to Pre-Calculus. We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your radio host, Miss Eloisa Jen G. Taggart from Tagum City National High School. How are you feeling now, my dear students? I hope you are well and comfortable wherever you may be. At this time, I must ask you to stay in a comfortable, well-ventilated and well-lit area where you can listen intently and take notes. Are you ready? That's great! Come and join us. Stay tuned and be a one-of-a-kind Matalino student. Our lesson for today will be Parabola. This topic will be brought us today by our radio teacher, Miss Princess Clarice Joy M. Saludes from Tagum City National High School.
Good day, grade 11 students. I hope you are all doing well and excited for today's lesson. Another day to get to know more about pre-calculus. Bring out your pen, notebook, and especially your pre-calculus quarter 1 module 1. At the end of this lesson, you should be able to define a parabola and determine the standard form of equation of a parabola. We have learned the general concept of conic sections and its first type, the circle. We've also seen rough sketches of other types of conic sections. Now, let's learn more about the parabola. Parabola is another kind of conic section, and aside from mathematics, parabolic curve has physical applications in physics, astronomy, wireless communications, industry, solar energy, engineering, and even optical illusions. Applications of parabolic curves often require specific information about the curve, especially involving the focal point. To start our learning process, let's have a short activity first. I will present situations and let's try to answer some follow-up questions. Are you ready? Let's begin. During your younger years, some of you were fond of hunting spiders at night with your friends. You use portable flashlights as your source of light in the dark. Can you still remember how the light appeared on the ground when you point the flashlight at an angle slightly inclined downwards? The light appeared in a U-shaped curve, right? Great! Let's have another example. Creamline Cool Smashers and Sherry Tigo 7 Pro crossovers had their longest rally during their championship match on the 2021 Premier Volleyball League Open. While the ball was in play, what shape of curve did the motion of the ball make? The motion of the ball creates another U-shaped curve, right? Just like our first situations, these U-shaped curves are called parabolas. Now, what is a parabola? The parabola is a conic section whose eccentricity is 1. Parabola is the curve of points equidistant from a fixed point F and a fixed line L, not containing F. The fixed point in this conic is called the focus, plural is foci, and the fixed line is called the directrix. In this figure, note that the distance from the vertex to the focus is P. The distance from the directrix to the vertex is also P. The distance of the vertex to the focus and vertex to the directrix is equal. The undirected distance from the vertex to the focus by the letter P will always be considered as positive. In this figure, let us have the parts of the parabola. The fixed point is called the focus, while the fixed line is called the directrix. The axis of symmetry divided the parabola into two parts. The vertex of the parabola is a point that lies on the axis of symmetry. The distance from the vertex to the focus of the rectrix is called the focal distance. The latus rectum is a segment containing the focus, with endpoints of the parabola and perpendicular to the axis of symmetry. There are two cases in which a parabola is positioned or situated, meaning its vertex may be at the origin denoted as 0 and 0 or any point in the plane HK. Let us determine the standard form of the equation of a parabola with vertex at the origin. The standard equation of a parabola with vertex at the origin is y squared equals 4px. We have four orientations of the opening of a parabolic curve. The technique on determining the direction of a parabola's opening is by observing which variable is being squared. For example, in the equation y squared equals 4px, the squared variable is y, and x is not, hence the parabola's orientation is horizontal, and it opens sideward, either left or right. To exactly determine where the parabola faces, we observe the sign of 4p, or the equation's right-hand side. If it is negative, it opens to the left. If it is positive, then it opens to the right. These rules also apply when the parabola's orientation is to the y-axis. The only difference is that if the squared variable in the parabola's orientation or equation is x, the parabola's orientation is vertical, and it opens either upward or downward. Amazing, right? I hope you're still following our discussion so far. Let's proceed. Let's take a look at this equation again. Y squared equals 4px. The focus of the parabola is P and 0, where P is the focal distance and 0 since the vertex is at the origin. Also, our parabola's orientation is to the x-axis, and it opens to the right. Let's take a look at this equation again. Y squared equals 4px. The focus of the parabola is P and 0, where P is our focal distance and 0 since the vertex is at the origin. Also, our parabola's orientation is to the x-axis, and it opens to the right. The directrix is x equals negative p, since it is equal to the distance from the vertex to the focus, and we can illustrate it by counting p units from the vertex opposite to the direction of the focus, and drawing a line perpendicular to the x-axis of symmetry. Since our parabola is at the x-axis, our axis of symmetry is horizontal, so y equals 0. Let us have some examples for each orientation. Also, we will identify its vertex, focus, directrix, axis of symmetry, latus rectum, and the length of the latus rectum. Let's have our first example. X squared equals 4y. The first thing that we should notice is the variable that is being squared. Since we have the variable x, hence the orientation of this parabola is towards the x-axis. Since the parabola or the equation given is positive, the parabola opens upward. After that, let us now try to get the focal distance. Always equate the right-hand equation with 4p. Hence, we get 4p equals 4, then p is equal to 1. Let us get the length of focus to one of the endpoints of our latus rectum, using 2p. So, we will substitute the value of p so the equation, now we have 2p equals 2. Since our parabola is at the origin, vertex is 0, 0. We also have our focus 0p. Then we have 0, and 1. Directrix is equal to y equals negative p. Then we have y equals negative 1. Since the orientation of our parabola is towards the y-axis, we have the axis of symmetry, x equals 0. We have our two latus rectums. We have LR1 is 2 and 1, and LR2 is negative 2 and 1. We also have our length of the latus rectum, P equals 4 units. Let us have our second example, x squared equals negative 8y. Just like that, we have done on the first example, the orientation of the parabola is towards the y-axis, and this opens downward. Focal distance is P equals 2, and 2P as the length of focus to one of the endpoints is 4. Hence, we have our vertex 0, 0. Our focus is 0 and 2. Directrix is y equals 2, and the axis of symmetry is x equals 0. Let us have our latus rectum. We have our LR1, 4, and negative 2. Our LR2 is negative 4 and negative 2. We also have the length of our latus rectum. Let's have 4p equals 8. For our third example, let's have y squared equals 12y. We have our p equals 3. The orientation of our parabola is towards the x-axis. Hence, we have our vertex at the origin 0, 0. The focus is at 3, 0. Directrix is x equals negative 3, and the axis of symmetry is y equals 0. We have our LR1, 3 and 6, LR2, 3 and negative 6, and the length of our latus rectum, 12 units. Let us have our fourth example, y squared equals negative 1/2 y. The focal distance of our parabola is 1 over 8. The orientation of our parabola is towards the x-axis. Hence, this opens to the left. The vertex of our parabola is at the origin 0, 0. The focus of this parabola is negative 1 over 8 and 0. We have the directrix x equals 1 over 8. The axis symmetry of this parabola is y equals 0. We also have our latus rectums. LR1 is negative 1 over 8 and 1/4. We have our LR2, negative 1 over 8 and negative 1/4. The length of our latus rectum is 4p equals 1/2 units. We are done with the standard form of equation of parabola with vertex at the origin. Let's now move to the standard form of equation of parabola with vertex at any point hk. Just like how we did when the vertex is at the origin, we can determine the orientation of the parabola when the vertex is at any point. We can determine by observing the variable that's being squared. Let's have the standard equation x minus h squared equals 4p quantity y minus k. By looking at the equation, we can easily determine the orientation of the parabola and where it faces. Since the squared variable is at x, then the orientation of our graph is towards the y-axis, and this faces upward. Let us have another equation. Y minus k squared equals negative 4p quantity x minus h. What do you think will be the orientation of the parabola if the equation follows this form? Very good. The orientation of our parabola is to the x-axis, and it opens to the left. Let us do the same routine that we did on the first part of this lesson. Let us observe the variable that is being squared. Since we have the variable x and the right-hand equation is negative, then our variable or the parabola opens downward. Let us now solve for the focal distance. We have negative 4p equals negative 1/2. This we have p equals 1 over 8. Now, let us solve for the focal distance. We have negative 4p equals negative 1/2. Hence, we have p equals 1 over 8. Now, let us solve for the length from focus to one of the endpoints of the latus rectum using 2p. So, we will substitute the value of p so the equation. Now, we have 2p equals 1/4. We now have our focal distance 1 over 8. Let's have our vertex. The vertex of this parabola is negative 1 and 2. We also have our focus. We are going to substitute our values, h and k minus p. Then we have negative 1 and 15 over 8. We also have our directrix, y equals k plus p. Then we have y equals 17 over 8. We also have the axis of symmetry, x equals negative 1. We also have our two latus rectums. We have LR1, negative 3/4 and 15 over 8. LR2 is negative 5 over 4 and 15 over 8. The length of our latus rectum is 4p. Hence, we have 1/2 units. Let us have our second example. X minus 1 squared equals 8 quantity y minus 4. We have the focal distance 2. The vertex is 1, 4. The focus is 1, 6. Directrix is equal to 2. We have also our axis of symmetry, x equals positive 1. The latus rectums are 5, 6, and negative 3 and 6. The length of our latus rectum is 8 units. Let us now have our third example. Y minus 3 squared equals negative 12x plus 4. Our focal distance is 3. The vertex is negative 4 and 3. Our focus, h minus p and k, we are going to substitute our values, hence we have negative 7 and 3. The directrix of this parabola is negative 1. Our axis of symmetry is y equals 3. Our latus rectums are negative 7, 9, and negative 7 and 3. The length of our latus rectum is 12 units. We are now down to our fourth example. Y minus 1 squared equals 8 quantity x minus 4. The focal distance of this parabola is 2. The vertex is 4 and 1. We also have the focus of this parabola, h plus p and k. Hence, we have 6 and 1. The directrix of this parabola is x equals 2. The axis of symmetry is y equals 1. The latus rectums of this parabola is 6 and 5 and 6 and negative 3. The length of our latus rectum is 8 units. You all did well. It may be confusing at first, but that's understandable since you're just beginning. Remember though, that practice makes us better in everything. Let us have a short assessment. Please make sure to have your pen and notebooks with you. Please choose the best answer. Let us start. Number 1. The undirected distance from the vertex to the focus of the parabola is represented by blank, which is always considered as positive. A, E, B, P, C, Y, D, K. The correct answer is B. Did you get it right? Let's have the second one. Number 2. This is the standard equation of a parabola with vertex at the origin, axis on the x-axis, focus at P, 0, and directrix at x equals negative p. A. X squared equals 4px. B. Y squared equals 4py. C. Y squared equals 4px. Or D, x squared equals 4py? The answer is letter C. Great job! Let's have number 3. Number 3. Which among the following does not constitute a parabola? A. Projectile motion. B. Bottom support of the Eiffel Tower. C. A downward U-shaped path in a roller coaster. D. A car tire. The correct answer is letter A. Let us have number 4. If a parabola with the center at the origin opens downward, it means that A. The focus is at 0p. B. The focus is at p0. C. The focus is at 0 and negative p. Or D. The focus is at negative p and 0. The correct answer is letter D. Let us have our 5th one. By inspection, the parabola of the equation y minus k squared equals negative 4p quantity x minus h. This will likely be equals blank. A. Opens to the left. B. Opens to the right. C. Opens downward. D. Opens upward. The correct answer is letter C. Let's have item number 6. Which of the following illustrates parabola? A. Firing a missile. B. Ocean waves. C. Predicting profit. D. Population growth. The answer is letter C. Let us have the 7th item. It is a curve where any point is at an equal distance from a fixed point and a fixed straight line. A. Circle. B. Parabola. C. Ellipse. D. Hyperbola. The correct answer is letter A. Let's have the 8th item. What is the opening of the graph of y minus 1 squared equals negative 4 quantity x plus 1? A. Opens upward. B. Opens downward. C. Opens to the left. D. Opens to the right. The correct answer is letter B. Let's have the 9th item. Determine the vertex and focus of x plus 5 squared equals 8 quantity y minus 3. A. Vertex at 5, 3 and focus at 5, 5. B. Vertex at 5, negative 3 and focus at 5, 5. C. Vertex at negative 5, 3 and focus at negative 5, 5. D. Vertex at negative 5, negative 3 and focus at negative 5, 5. The correct answer is letter C. Let's have the last item. The receiving dish of a cable TV is in the shape of a paraboloid of revolution. Find the location of the receiver which is placed at the focus if the dish is 8 feet across and 2 feet deep. Which equation best describes the problem? A. Y squared equals 8x. B. Y squared equals negative 8x. C. X squared equals negative 8y. Or D. X squared equals 8y. The correct answer is letter A. Did you get it right? To further understand and enhance your skills in solving, you can answer the activities provided in your modules. Thank you so much for being with me in this lesson and see you on our next episode.
Thank you, Teacher Clarice. That ends our lesson for today. For you to understand our lesson further, you may do all the activities provided in your modules. You may also have an advanced study of your topics to prepare yourself for next lesson. Please make sure to be with us in next session. This has been Miss Eloisa Jan G. Taggart, your radio host. Keep safe, everyone.
Na 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 na, dapat Tagum radyo eskwela na. Na 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 na, dapat Tagum radyo